Hello student, welcome back to my channel Kunal sir at JEE NEET Chemistry World. So today's topic of discussion is Bohr Atomic Model. The last class we discussed very important topic on Rutherford Atomic Model. The Rutherford demerits was there and that demerits overcome by the scientist Niels Bohr, and he proposed a atomic structure, and because of that 1912 he got a Nobel Prize. Now we are going to learn several things on the Bohr Atomic Model. How the Bohr Atomic Model, main points of Bohr Atomic Model. First, he nullified like that the demerit of Rutherford model like this way, that whenever electron moving in a particular orbit, moving in a particular orbit, then it is neither absorbing energy, nor releasing energy. That means the state of electron in a particular orbit is a constant which is called as a stationary state. So that means the other part was same. What is he told? That there is a nucleus in a small place of the atom. Around the nucleus, electron moving in a circular path which is called as a orbit. All those part was same, but only he proposed that when electron moving in a particular orbit, it is not absorbing energy, not releasing energy. The energetically it is in a stationary state. When there is electron is going from one orbit to another orbit, then only question of a exchange of energy, that means either absorption of energy or release of energy will come into the pictures. So then when electron jumping from one orbit to other orbit, it may be higher energy to lower energy or lower energy to higher energy, from one orbit to other orbit, then only absorption or emission of energy will come into the pictures. Emission of energy will appear. If electron is going lower energy to higher energy, it will absorb the energy. When it will come higher energy to lower energy, it will emit the energy. And now that delta E will be equals to always the difference of two energy level, like E2 minus E1. I am telling E2 has a higher energy than E1, and always we know delta E equals to what? H nu, and which is nothing but a hc by lambda. Nu is a frequency, h is a Planck constant, c is the velocity of light. So now h value already everybody knows, 6.6 into 10 power of minus 34 joule second. C is the velocity of light, 3 into 10 power of 8 meter per second. Nu is a frequency, where lambda is a what? Wavelength. Frequency or wavelength are what? Inversely proportional. So that is the idea. When that difference of energy will come into the picture, when there is a absorption of energy will be there, that means electron is going from lower energy to higher energy orbit, and difference of energy has to be absorbed. And when electron is coming higher energy to lower energy, then energy has to be what? Release. And that is delta E. Delta E will be equals to E2 minus E1, higher energy minus lower energy, this difference. And now next important point, when electron is moving in a particular orbit, then orbit angular momentum will be equals to mvr equals to nh by 2 pi, where n is a orbit number and m is a mass of electron. V is a linear velocity of electron, where r is the radius of orbit, radius of orbit, radius of orbit, and h is a Planck constant, n is a orbit number, pi is 3.14, everybody knows. Now based on that, next what we can derive the radius of nth orbit of Bohr and what will be the energy expressions of the nth orbit of Bohr. Now whenever electron is moving in a particular orbit, suppose there is a nucleus and now here electron is moving in a particular orbit, then inward there will be one force of attractions which is called as a centripetal force or electrostatic force, and then when rotational motion is there, outside one force will be there which is nothing but a centrifugal force, and inward force will be nothing but a centripetal force. Now whenever these two forces balance, then the inertia of movement of electron will be there in this direction. That's why electron is there in a circular path. Now centripetal force is the electrostatic force of attraction. Suppose the JEE unit is there, Z is the atomic number, that many number of proton is there in a nucleus. The magnitude of the charge of the electron and the charge of the proton, their magnitude are same, only sign are different. Both are 1.6 into 10 power of minus 19 coulomb, but electron is a negative sign, proton is a positive sign, but both have a same amount of charge. So that's why both expressed, electron also expressed by E and proton also expressed by E. And proton, this is representing the proton, that many Z number of proton, and this represent the electron. Now when they will feel that force of attraction, electrostatic force of attraction, we used to apply the Coulomb's law. If there are two charges there, one Q1 and Q2, and between them distance is r, then Coulomb's law is telling their electrostatic force of attractions which will be equals to K into Q1 Q2 by r square, Q1 Q2 by r square. This is the Coulomb's law. And if I apply that Coulomb's law over here, I will get a centripetal force. Centripetal force is the electrostatic force of attractions which will act towards the center. Centrifugal force outside of center. When the two forces will balance each other, then only electron is moving in that circular path. And now we are balancing that things, JE into E. And now with that, before that K will be there, which is constant factor. K will be equals to 1 by 4 pi epsilon naught. Epsilon naught is a permittivity factor. Now K into ZE into E by the distance between them, if it is r, then it will be r square, which will be balanced by centripetal force. Mass of electron is m, linear velocity is v, mv square by r. We can show you that as per the Newton's second law, that mass into acceleration is a force. Centrifugal force is, force means what? Mass into acceleration. As per the Newton's second law, we can prove it by that model. V square by r is a acceleration multiplied by mass is nothing but a centrifugal force. But that is not required here itself. Only you need to know that one. This is your centrifugal force, this is your centripetal force or electrostatic force of attraction which has to balance each other, then only electron moving in a circular path. Now here immediately you look at this r and this r, one power cancel out, then we are getting mv square will be equals to k into z square by r. We are getting these things. Now if I write down here itself again, MVR will be equals to NH by 2 pi, or from here I can write down V square equals to KZ square by M into R. This is I can write down from over here itself. Now from here what I can write down, MVR will be equals to V equals to NH by 2 pi MR. I can write down, then V square will be equals to N square H square by 4 pi square M square R square. I can write down. Now both are representing the linear velocity. We can equate them. Then immediately what I can write down? KZ square by MR will be equals to, these two we are equating. These two equating. So then immediately KZ square by MR which will be equals to N square H square by 4 pi square m square r square. Now you look at this r and this power is cancel out. Then my r will be equals to here m and these things cancel out. Then this r, if I take this side, then what I will get over here? N square h square by here you look at k z square, then 4 pi square and m. I will get like this expression. If you put the value over here, all the value, that means h value, k value, E 1.6, pi value, mass of electron, ultimately these things expression in, you need to remember this much thing, you need not to remember from where it is coming. I am showing you. Then expression of Rn, n square is there, here z is there, then immediately 0.529 n square by z in angstrom. Picometer, it will be nothing but a 52.9 into n square by z. This will be in picometer. And angstrom to meter, if you want to convert, you have to multiply it with this 10 power of minus 10. Centimeter 10 power of minus 8. You can do. But these things you have to, compulsory you have to remember these things. Now based on that, we can go with a few explanations. Remember Rn equals to 0.529 n square by z. We will utilize this one. And another things you remember, mb square equals to what we get? Kz square by r. These 2 points. mb square equals to, we got kz square by r. These things we need to remember, and Rn will be equals to 0.529 n square by z. Now next you look at, if I write down that two things over here, Rn equals to, we got is 0.529 into n square by z in angstrom, and my mb square will be equals to my kz square by r. These two expression we will utilize. Now if you look at, for hydrogen atom, Bohr model will be applicable for hydrogen atom or hydrogen like atom. Hydrogen like atom means single electronic system. Hydrogen like atom means what? I can write down He plus, I can write down Li plus 2, I can write down B plus 3, all have a single electron. So then this model will be applicable for hydrogen atom or hydrogen like atom. So now here for hydrogen atom, you know very well my dear student, Z will be, atomic number will be equals to 1. Now from this expression if I write down, and for first orbit what will be the radius? N equals to 1. Then that time my R1 will be equals to, N is the orbit number, R1, that is the general expression. Then my R1 will be equals to 0.529 1 square by 1 angstrom, which is nothing but a 0.529 angstrom. Now if I put this Rn equals to, what I can put? 0.529, already expression is there, n square by z. Instead of 0.529, I can write down R1 of hydrogen into n square by z. That means this expression I can utilize for hydrogen atom or hydrogen like atom. Rn will be equals to R1 into n square by z. Now Z is a atomic number, N is a orbit number. Z is a atomic number of that element, and N is a orbit number. Yes or no? Orbit number. Now if you look at over here, now after that we are going to the energy expression. How we can calculate the energy? Now energy will be equals to, total energy will be equals to kinetic energy plus potential energy. That means energy of an electron in a particular orbit, which is nothing but a kinetic energy plus potential energy. Kinetic energy equals to, everybody knows, half into mass into velocity square. Potential energy means what? Potential energy, suppose if you have a two charged particle, here Q1, here Q2, in between distance is R, then potential energy will be equals to Q1 Q2, K into Q1 Q2 by what? R. If the like charges is there, sign will be positive. One unlike charges is there, that means 2 plus positive sign, 1 plus 1 minus negative sign. But here electron and nucleus, electron is a negative charge, nucleus is a positive charge, sign will be what? Negative. Plus minus means attraction. plus plus repulsion, minus minus repulsion. So that's why here that sign will be nothing but your positive sign, negative sign, because positive and negative is there. So that's why potential energy will be equals to K into one is JD, another one is E, and in between distance is R, because the radius of the orbit. Now immediately instead of half mv square, what I can put over here? Already you look at mv square equals to kz square by r. Then immediately I can put kz square by 2r. I can put like these things, as or no? So now I can put like these things, kz square by mv square equals to kz square by r. So that means we are getting here kz square by 2r, and here you have a kz square by r. That means ultimately you are getting minus of kz square by 2r. That means what I can write down by saying this, my total energy is nothing but you look at kinetic energy kz square by r, then total energy equals to minus of kinetic energy. That means already the kinetic energy, if you look at kinetic energy is nothing but this value, and same value, only before that minus sign is there. So that's why total energy equals to minus of kinetic energy. So instead, before kinetic energy, if you put the negative sign, you will get the total energy. Now same way if you look at over here, potential energy versus total energy expression. Then if you look at with the potential energy, if you multiply it by half, then you will get a what? Total energy. So then total energy will be equals to half into potential energy. Both are negative sign, but potential energy, if you multiply it by half, you will get a total energy expression. These two relation is very important. Sometimes they used to give you total energy or kinetic energy of the electron. Then from there I can get in that orbit what will be the total energy. Will apply this relation. Then sometimes they will give potential energy of electron in a particular orbit. Applying this relation, I can get the total energy. This is the idea. Now another important point, that how to derive the energy expression. Total energy, if I got this expression. Now in this expression all parameters are constant. If you look at very well. Now this k part is constant. You have a z, E charge is constant. That means charge of electron or proton 1.6. Their magnitude are same. And then by 2r. R, instead of R, if you put 0.529 is constant, but Rn equals to what we know? Na square by z. So instead of R, if you put Na square by z, that means z will go up. That means my energy expression used to come, En will be equals to, and all other value if you put, it used to come 13.6 z square by n square. You look at this, z will come up. That's why z square by n square. All other part, if you put the value, ultimately expressions come in energy of nth orbit, electron in nth orbit, minus 13.6 z square by n square electron volt per atom. In joule it will be minus 2.18 into 10 power of minus 18 joule, that will come. And now this is the very basic idea we discussed. Energy expressions, radius of nth orbit, how potential energy, total energy, they are connected. All those points I told. Now the last important point, if I ask you the time taken for one complete revolution of an orbit by electron, that value will be how much? Now, or how they proportional to the n and z. Already you know that velocity equals to, if you look at over here, from here what I can write down? My v square will be equals to kz e square by mr. Now these k, m, e are constant. Instead of r, what I can write down? kz e square m into, instead of r, 0.529 and n square by z. n square by z. Now you look at all other part, this part and this part, this part will be your constant. Then ultimately z will go up. Now immediately I will get v square proportional to z square by n square. That means my v proportional to what? Z by n. Now we got V proportional to Z by N. Z is a constant. That means velocity of electron in a particular orbit inversely proportional to the radius number of that orbit. N is a radius number. So now, or principal quantum number, whatever you call it, later we will introduce that one. Now V proportional to Z by N. Now total, here I am telling time taken for one complete revolution of an orbit by an electron. That means electron is moving in a particular orbit. If it is your nucleus, electron is moving. Then that time period T will be equals to, and radius of the orbit is r. That total distance is nothing but how much? 2 pi r. How much velocity it is moving? With a wave velocity. Now r equals to, what is my expression? N square by z. Then immediately what I can put instead of r? 2 pi into some constant is there, which is n square by z. And instead of velocity, velocity is proportional to what? Z by n. Then immediately you look at n will go up, then this factor used to come, then t will be proportional to n cube by what? Z square. That means the time period for one complete revolution, that will be equals to n cube by what? Z square. You look at here, n square by z is there, below denominator v is there, instead of v we put z by n will go up, and this part is a constant, then n cube by z square. So that's why time period for one complete revolution, that will take proportional to how they will proportional, that means orbit number cube by atomic number square. Is it clear or not? I hope I able to give you clarity to everybody. Next class we will discuss different problem based on this orbit energy expression, and we will proceed to the next topic. To get and more this type of video and to get a confident over the subject, please have a look, refer to the student, and got the clarity of the chemistry subject and score high in your JEE Mains and JEE Advanced exam. Thank you very much. Thank you all, my dear student.